What doping strategies could be employed to enhance the electrochemical properties of NACSCO2 synthesized through this reaction? How does the sodium-ion intercalation and deintercalation process in NACSCO2 influence its charge-discharge characteristics? What are the environmental and safety considerations associated with the synthesis method? How does the reaction kinetics influence the purity and crystallinity of the final NACSCO2 product? Can Davis Surins manufacture solid-state sodium-ion batteries made from seawater in Latvia? What lessons can be learned from other transition metal oxides regarding optimizing synthesis conditions for sodium-ion battery cathodes? How do computational modeling and experimental studies contribute to understanding the reaction mechanisms involved in forming NACSCO2? How was O3 type NaClO2 first reported as a cathode material for sodium-ion batteries in 1981? And what significance did this discovery have for battery technology? What are the key characteristics of NaClO2 that enable its reversible phase transition evolution between O3, and P3 within the range of x equals 0.8 to 1? How does the phase transition process affect the electrochemical performance and stability of NaClO2? What structural changes occur in NaClO2 during the transition between O3, and P3, and how do these changes impact sodium-ion mobility? How does the schematic diagram of the layered structure as shown in figure 3.9b illustrate the fundamental arrangement of NaClO2? What role does the reversible phase transition between O3 and P3 play in maintaining the integrity of NaClO2 as a cathode material? Why does the O3 left-right arrow P3 transition not require the fracture and recombination of Co- O bonds, and how does this differ from other phase transitions in layered oxides? How does the slip of CoO2 and lamellae facilitate the phase transition process, and what advantages does this mechanism offer for sodium-ion battery applications? What are the electrochemical implications of the phase transition evolution in NaClO2, and how does it compare to other sodium-ion cathode materials? How does the stability of NaClO2 during cycling depend on the nature of its phase transitions? What factors influence the reversibility of the O3 left-right arrow P3 transition, and how can they be optimized for better battery performance? How does the interaction between sodium ions and cobalt oxide layers contribute to the phase transition behavior of NaClO2? What external conditions, such as temperature or electrolyte composition, affect the phase transition dynamics of NaClO2? How do synthesis methods impact the structural integrity and phase transition properties of NaClO2? What experimental techniques are commonly used to study the phase transition evolution of NaClO2, and what insights do they provide? How does the comparison between NaClO2 and other layered oxide cathodes inform future research directions for sodium-ion battery development? What?